This is one way in which we've definitely improved on those lines, okay? So, algebra is really about two things. It's about groups, and it's about operations. Okay? And so this is from a very abstract point of view, and it'll make sense, trust me. Okay, just lean in and you'll understand what I'm trying to get at here. So an operation is something that you do to a group. So for example, addition is an operation, okay? Subtraction, multiplication, division. Can somebody else give me another operation that we do that's not listed up there? We did both of them yesterday. Square something? Yeah. Absolute value is an operation. All sorts of operations, other than addition, subtraction, multiplication, division. And without a doubt, our brain works best with addition and multiplication. Those are kind of right up our alley, okay? That's how our brain is wired, okay? So if you're like, oh yeah, division was always tough for me. Yeah, that's pretty normal. Don't feel bad about that. Then we have groups. We have things that we operate on. Here's an example of a group. We have numbers like 5 and 6, okay? We can operate on fractions. We can add, subtract fractions. So like, say like 1/3 and 3/7, okay? You can also operate on algebraic expressions. So for example, suppose I have like x minus 3 over 2x plus 4, okay? You can take two things and divide them. This all looks very similar to the algebra that you know, right? Today, I teach you a new operation. You don't know it. And that's weird because right now you become very much ingrained in these type of operations, right? So right away, you're going to see this operation and you're going to try to classify it as an operation you already know. Don't. It's not one of these. This is the operation, and it's called composition. It looks like that. It's called composition. There's certain groups that you can do composition with. You can't do composition with numbers. You can do composition with functions. Functions are a group that we can operate with as well. Okay? So, this is the operation right here. F of g of x. That's how you read that. F composed of g. F of g of x. It's defined as f of g of x. These two things mean the same thing. This is not difficult. I don't want you to get this wrong on the test. Everybody can do it. I'm so frustrated when I give this and then afterwards a third of the class gets it wrong and I say, how did that happen? Look, I never knew how to do it. It's not tough. Trust me. We can all do it. What this means is you take x, that's your domain value, that's what you start with, and you drop it in, you first drop it into the g function, okay? And it produces an output. It produces g of x. What do you think you then do with g of x? Yeah, you plug it in for f. And the output is f of g of x, otherwise known as f of g of x. So it doesn't mean multiplication, okay? It's not parentheses. It means that you're taking g of x and plugging it back in for f. So you can see that this is a domain value, and it spits out a range value, okay? That in turn then becomes a domain value, and then spits out to a range value. So that's kind of what it's like. It's exactly what it's like. And we're gonna keep it very straightforward, okay? The application of composition functions, it's like, why would somebody want to do that? You have to, if you don't have composition, calculus becomes almost impossible, okay? Super, super difficult. Composition is absolutely essential to being able to understand calculus. So you won't use it much the rest of the year at all, but we will in tomorrow's lesson a little bit. By the way, is anybody gone tomorrow? I heard there was like a field trip.
Me and Piper will be if she's here.
Where?
Minneapolis.
Oh, you're going on the museum thing.
Basilica and then Moss.
Cool, good for you. I hope you guys have fun. That's all good. It's all good. I'll record a video.
Okay.
All right. So this says to compute f of g of 0. And what that means is I'm going to take 0 and I'm going to plug it in for g. So I have 0 squared plus 2 times 0. And notice I get 0 plus 0 is 0. Okay, that's not the result. That's what g of 0 is. I now then take that 0 and plug it in for f. And so I have 2 times 0 minus 3 is negative 3. Try a few examples here. Here I take 0 and I start by plugging it in for f. If you plug 0 in for f, what do you get? Negative 3. So this becomes g of negative 3. Now you plug negative 3 in for g, and you get negative 3 quantity squared plus 2 times negative 3. Negative 3 squared is 9, and then 2 times negative 3 is negative 6, and I get 3. So here's something that's interesting. Is 5 times 2 the same thing as 2 times 5? Can you take two numbers that are multiplying and switch them around? 5 times 2 is the same as 2 times 5? Yeah. Is 5 divided by 2 the same thing as 2 divided by 5? No. So some operations are what we call commutative. You can move them around. Look at this one. You have f of g of 0 and g of f of 0. They produce different values. They are not commutative. So order matters with composition. It matters a lot. Okay, let's try this one. I have f of g of negative 1. Okay, what this means is f of g of negative 1. So I'm going to start by plugging in negative 1 to g. You always start with the one that it's closest to. That's where you plug it in. And if I look at my rule here, I would have negative 1 squared plus 2 times negative 1. And I get 1 minus 2 is negative 1. What do I do with that negative 1?
Put it into F.
Yep, plug it into f. So now negative 1 goes in for f, and I get 2 times negative 1 minus 3, and I get negative 5. That's my result. You try letter D on your own. Try D on your own. I started by plugging in -2 for f, and I got -7. So then I plug in -7 for g, and -7 squared is 49, and 2 times -7 is -14. That comes out to be 35. Not too bad. Letter E, this says f of 1. So now what I do is I'm going to take, so f is 2x minus 3. So I'm going to plug 1 in, and I get 2 times 1 is 2, and 2 minus 3 is -1. So now I don't go to g, I just go back to f again. Now I do 2 times -1 is -2, minus 3 is -5. You try letter F on your own. Give it 15. All right, we're going to skip letter H, and we're going to skip letter J. How are letters G and I different from the ones we just did? The ones we did had numbers, right? These don't have any numbers. So watch what I'm going to do. I know that F is equal to 2x minus 3. And I know G is equal to x squared plus 2x. Okay? So now what I'm going to do is if it says f of g of x, I take what g is, and instead of plugging a number into x, I plug the whole expression in for x. See that? So I'm going to write parentheses around it. It becomes 2 times the quantity x squared plus 2x, and then I have a minus 3. Or in other words, 2x squared plus 4x minus 3. That's what f of g of x becomes. Letter I want you to try that one on your own. It's very similar to what we just did. You're going to do f of x. F of x. So I took the 2x minus 3 and I just dropped it right in for x. So I have 2 times the quantity 2x minus 3 minus 3. Or 4x minus 6 minus 3, which is 4x minus 9. All good with that? Good. So composition, is it new? Yes. Is it difficult? Not too bad. Let's go to the back side. We're now going to do composition using a graph. We're going to try a couple of these, not all of these. We'll do a few of them. The first one says f of g of 1, okay? So what that means is I first plug in 1 for G. If you remember yesterday, we did a graphical example. Notice that G is the red function. I know you guys don't have red on yours. You just have boring, boring lines. There we go. We're going to make that one red. If I plug in 1 for G, the output is 3. So this then becomes f of 3. Then I'm going to take 3 and plug it into f. F is the blue one, and I can see that the output is -1. I'm going to do another one with you, and I'm going to have you guys do 2 on your own, okay? G of f of -2. I start by plugging -2 in for f. What is f of -2?
2.
Positive 2. So this becomes G of 2. What is the height of G at 2? F is -2.
Oh, wrong line.
Exactly. And that's probably the mistake that happens a lot, is we go maybe to the wrong graph. And I do that all the time. So I get positive 2 out of that. Okay. I want you to do G of f of 1, see what you come up with. And then I'd like you to do f of G of -5. Try those two. You guys know 30 seconds. Yesterday was Will Doppelhammer's birthday, and I forgot to celebrate. We're going to celebrate 8th hour today. All right, we start with f of 1. I locate 1. F is the function below it, so that becomes -1. Now I plug in -1 for G. You can see that they both have a height of 1, so 1 is accurate. Any question there? And then the next one, I'm going to go ahead and plug in -5 for G. And when I plug in -5 for G, G is the red one. So I get -3. So it becomes f of -3. And then f is the blue one, so if I plug in -3, I get +3. We saw numerical outputs, we saw algebraic outputs, and then we did these graphical ones right there. So let's look at your homework. Yep, so you can see this page right here. Now you guys can go ahead. You have very similar to what we followed with. You just have this one page. You have numerical examples, some algebraic expressions, and then obviously you're going to have some graphical ones there at the end. Answer keys posted.